Hi students, this is the video for section that covers section 11.7 and 15.1. So I'll be going back and forth between those two chapters, and I will actually start in section 15.1 because it talks about and let me expand the window here really quick. There. Because it starts with telling us to write in standard form and to determine A, B, and C. A, B, and C, those are the coefficients of x, the coefficients of x, the coefficients of x, except for you don't see that x here because we don't write it, because that's the same thing as x to the 0 power, okay? But it is, so -5 would be the coefficient of x to the 0 power, okay? Yeah, in case you didn't know, that means 1. Okay, so if we want the expression to be in standard form, then we need to write the quadratic in this form, and the leading coefficient has to be positive, okay? Positive, and the leading coefficient, the leading coefficient has to be positive, and the leading term has to have a power 2. Okay, write in descending order, and that's in standard form. All right, so that's what I have to do here, and here my A is 4, my B is 7, my C is -5. Don't forget the signs, okay? Okay, so what about this one? Again, write it in descending order and make it equal to 0, because this 9 needs to be on this side. So you need to move that 9 by subtracting 9 from both sides. And now you are here, and now look at the leading coefficient. Is it positive? Yes. Does the leading term have a power 2? Yes, it does. So this is in descending order, and that is written in standard form. Now look for your A, B, and C values. Make sure you don't forget the signs. Okay. Same thing for this one. We need to rewrite it as -4y squared. Subtract both sides. 5y from both sides. That turns into that. Here my leading coefficient is not positive, so I need to make it positive by multiplying times a -1 on both sides. -1 times negative, that makes that a positive 4y squared, which is what I wanted to do. Negative times a negative makes that a positive. Y equals -1 times 0, it's just 0. Okay, so now I'm here, and I'm ready to write the coefficients of my terms. And yeah, in the case of A, I write a +4, a B a +5, except for C I write a 0, since C is missing. C is missing here, therefore I write a 0. Okay, it still exists, but in this case it is 0. Okay, and that's the introduction there. because we want to solve by factoring. Okay, we want to solve by factoring, and now I'm moving to section 11.7. okay, just so you know where I am. And we are trying to solve quadratic equations by factoring. We already know how to factor quadratic equations, quadratic equations, and all we have to do now is solve for x. So the fastest way to do that is by setting the equations equals 0. Okay, so in this case they have already solved, they have already factored the equation and set it equals 0. Okay, so they have done that for us. All we have to do now is solve for x. So remember that the zero products principle tells us to that any value multiplied times 0 is 0. Okay, so in this case we have two factors here, and we have two factors here, so either one of these is 0. Okay, either one of those. So this allows us to write x plus 3 equals 0 and x minus 2, and you don't have to write parentheses, equals 0. Okay, because either of these two will be 0, we don't know which. So that allows us to do this, separate this equation into two different equations. Okay, however, you do have to have a 0 on this side, so you can separate them into two different equations. Okay, and then you solve for x. So use the addition principle, subtract both sides, x equals -3. Use the addition principle, add 2 on both sides, x equals 2. And now you have two different values for x. Now we're done. In this case, I told you to solve. That's what we did. We did right there. And to check it, just plug the values back into the equation and see if it makes the equation true. If it does, like it did here, then yes, you did the work correctly. Okay. Okay, let's move on to sample 2. Again, you gotta ask yourself, is it set equal to 0, equal to 0, equal to 0? Yeah. If not, make it equal. Yeah, make it equal to 0. And in this case, they have already factored it for us, so we don't have to do much except for rewrite it over here as two different equations, because it is already set up to equal 0. Already set equal to 0. So 5x plus 1 equals 0 is my first equation, and x minus 7 equals 0 is my other equation. Alright, now just solve for x. In this case, I'm gonna subtract, use the addition principle, subtract 1 from both sides, and 5x equals -1. I will divide both sides by 5. That gives me x negative 1 over 5. And then for this equation, I add both sides, 7 to both sides, and the answer is x equals positive 7. And then just plug in your values, the values you get for check. As a check, if it makes the equation true, then the solutions, those are solutions of the equation, and your work is correct. Okay. All right. So let's move on to this one here. Again, make sure you get you set it equals, the equation equals equal to 0, because that's what allows us to write it in two different equations, two different equations. X equals 0. So because x could either be 0 or this parenthesis could be 0, right? Oops, x equals 0 and 2x minus 9 equals 0. Alright, now you have two different equations. Solve for x. This one's already solved. Here I add 9 to both sides on this equation. That's 2x equals 9. Divide both sides by 2. That's 9 over 2. Can't simplify it. So the answer is x equals 9 over 2. 9 over 2. And again, as a check, you plug in your values into the original equation, and if it makes the equation true, then those are solutions of the equation. Okay. All right. So let's move on to. I'm still in the same section, except for I'm in objective B now. And now I'm going to start solving for x by factoring. So I'm going to have to do everything myself. The only thing I have to make sure of, again, is to write the equation in standard form. Write the equation in standard form, and the equation is to be set equals 0. Okay. So is this in standard form already? Yeah, because the leading coefficient is positive, and the leading term is has a power 2. So I'm ready to solve for x. Okay, so I'm just gonna go ahead and write over here x squared plus 5x plus 6. Now here. Okay, I know this is a quadratic. I know I'm gonna have two different factors because of this power of 2, right? I'm just gonna solve for by trial and error. Okay, I know my leading coefficient is gonna be, my first terms are gonna be x, and since both of these are positive, both sides have to be positive. 6, I need a factor of two factors that multiply out to 6 and add up to 5. So let me see, 3 times 2. 3 times 2 is 6, and 3 plus 5 is 5. So now that I have my two factors, oh, by the way, this is equal to 0, therefore this is also equal to 0, which is what allows us to set this as two different equations. 2 equals 0. Okay, just now solve for x. Subtract both sides, 3 from both sides. X equals -3. Subtract 2 from both sides. X equals -2. There I am. That's x equals -3 and x equals -2. Now just check your answers by plugging them into the original equation. Do it separately. If both equations are true, then those are solutions of the equation. Okay, and let's move on to this one down here. Okay, again, still the rules that applies here. Is this in standard form? Well, no, because this 16, -16 is on this side, and needs to be set equal to 0. Okay, so I will rewrite it over here so I can do my work on my paper. And I'm just rewriting now. X squared minus 8x equals -16. And then from here, I'm gonna add 16 to both sides. That becomes x squared minus 8x plus 16 equals 0. And now this is in standard form because of that 0 there. I mean that one little coefficient, and my power is 2 in my leading term. So now I know that I will use trial and error for this too, to factor it. So I know that my first terms are x. For my signs, I know that I'm going to need either a positive and a positive or a negative and a negative. This sign tells me which, so 2 negatives. Okay, so that's, I'm going to need 2 factors that multiply together give me 16, but when added together give me 8. So that will be 4 and 4, because 4 times 4 is 16. 4 plus 4 is 8. And now I set them equal to 0. So because this is what allows me to set this as 2 different equations. X minus 4. Notice that we have the same equation essentially. Therefore, well, let me solve for this one first. So I need to add both sides, 4 to both sides. The answer is x equals 4. And same thing for this one, plus 4. The answer is 4. So we only have one answer because both of them are the same. Therefore, x equals 4. Okay. And go ahead and plug it in to the original equation, see if that makes a statement true. If it does, if it makes the equation true, if it does, then that is a solution of the equation. Okay, so let me work on an example from section 15.1. It was this one here. Okay. Again, solve for x. So we need to ask ourselves, is the equation in standard form? Yeah, it is. Because the leading coefficient is positive and the powers 2, and it said equals 0. The only difference is that now we don't have the third term in there. We are missing a term, which is the constant. So I'm just rewriting here the equation. X equals 0 here. See, now I can see that I'm missing the constant here. Therefore, we don't have to factor by using the methods we learned, because here I can see that both of these have factors in common. So all I have to do is factor them out. I can see that 4x will be one of those factors, well, the factor in common in these two terms. And if 4x multiplied times x gives you back this term here. The sign is negative there, and 4x times 2 is negative 8x. Okay, 0. Okay, so now we have two coefficients here, and I can set them equal to 0. 4x equals 0, and x minus 2 equals 0. Okay. Now I'm ready to solve for x. I divide by 4 on each side, and x equals 0. Here I subtract 2 from both sides. X equals 2, negative 2, I mean. I have two answers. I mean positive 2. I need to add positive 2. So my so my answer is positive 2, not negative 2. Okay. And that's just another variation of that, what you will encounter, because here we are missing the constant. Okay. However, the term was 0. It was there, it just, the coefficient, one of those coefficients was 0. Therefore, we didn't write it. So it was in standard form. Okay. All right. Let me see. I believe I can work this one out first. Well, let me work out an easier version of this over here in section 11.7, which is this. And that's, let me fold the paper here. That's, and I'm just going to rewrite it. X plus 2 times x minus 2 equals 5. Okay, now I'm here. Oops. Now let's say, there you go. Is this in standard form? Well, no, because this is not set equals 0. Okay. Therefore, I need to subtract both sides. X plus 2 times x minus 2. Oh, minus 5. So minus 5 equals 0. Okay. So now it is set equals, the equation is set equal to 0 because however, still this is not in standard form, because watch what happens if we try to set this two factors equal 0. Well, if I multiply 0 times this is gonna make it, this is gonna get me 0. However, if I subtract 5 from 0, I'm gonna get negative 5. So the answer is not going to be 0, okay? So it doesn't make a difference if I make this a 0 or this one. The answer is still going to be -5. So I cannot use that principle, the setting my equations equal 0, because of this -5. Okay. So what I have to do, I'm gonna have to mix it up with this two factors. Okay. So these factors, I'm gonna need to mix them up, so I can add this -5 over to this, whatever this gives me. Okay. So I'm gonna we'll go ahead and multiply x times x is x squared, x minus x times -2 is -2x, x 2 times x is +2x, -2 times a +2 is -4, -4 divided by my 5, that equals 0. Combine like terms. In this case, this one cancel out, and then rewrite my x squared. Add these two together. That's -9 equals 0. Okay. So now I have I am here, and I have successfully combined this -5 into all of this. Okay. And now I can factor. I can see that this is a perfect square, so this has to be a difference of squares. For the first terms, we use a square root of x squared on the first term, and for the signs, since this is a difference of squares, I have to have a positive and negative value in there somewhere. Either this one negative and this one positive, or this one positive and this one negative. Okay. It's positive and this one negative. Alright, and then for the second terms, I use the square root of the second term, so in 3. Okay. And remember that this equals 0. This is what's going to allow us to set this as two different equations, and x minus 3 equals 0. Subtract both sides here. Subtract 3 from both sides. That's x equals -3. Add 3 to both sides here. That's x equals 3. So we have two different equations here, x and -3. X equals -3 and +3. Okay. -3 or +3, I should say. And then so let me go back to that example on section 50.1, because this one's a bit more complicated. Let me form my paper here real quick. Alright. Okay, so the problem is, let me rewrite it here. I'm just rewriting it now. Y minus 3 times y minus 2 equals 6 times y minus 3. Okay, so notice that this is not in standard form. Okay, not in standard form. What do we need to do? Well, first we need to set this equals 0 here, and then see, since I would be adding here if I want to move this term here over here, I'm gonna have to add, and if I add, well, let me go ahead and do that just so you can see that just so they can see that these are not all factors. If they were, then I will be able to set them up equal to 0. However, they're not, because I moved this one over here to this side by adding, when subtracting. So that wouldn't work. That wouldn't work. This is still not in standard form, okay? Because I could say this equals 0, or this one, but then you will still have to have this answer here, and this may or may not be well, because of this 6. Think about it, you're gonna get some integers here, so the answer is not gonna be 0, okay? So let's go ahead and, like we did with the last problem, we combine them together to see to combine like terms, and then go from there, okay? So let's go ahead and do that. I'm gonna multiply these two here. Y times y, what's y squared? Y times -2 is -2y. -3 times y is -3y. -3 times a -2 is +6. So negative is positive. All right. And on this side, I will combine these two by distributing this 6. 6 times y is 6y. 6 times -3 is -18. Okay, let's keep going. I will subtract 6y from this side. Oops, 6y. See, now I can combine my like terms here. Okay. And then subtract 18 from both sides too, 18, and combine them here. Okay, this side becomes 0. Combine my like terms, so I put them together so I could combine them there, just next to each other. I only have one y squared. Rewrite it. I have y's, I have several. Combine together by adding them. 3, 5 plus 6 is 11, so -11y. And then here add them up, add this up. That's a -12. And now I'm here. Okay. Alright. Okay, let's see. That is -6, 1, negative. No, that's a positive. That's a positive here. So I was supposed to add. If I add them together, that becomes 18 plus 6, 14. I mean 24. Okay. 24, and it is positive. Okay. Yeah. So this is 24. Now I'm here. Okay. I will use trial and error again to factor them. Okay. So for the first terms, I use y. For my signs, I need a negative and negative, or a positive and a positive. This sign tells me which. So it's two negatives. I need two factors that will multiply together, give me 24, and when added together, give me 11. So 8 times 3, okay? Because 6 times 3 is 24. Added together, you get 11. That's all of that is equal 0. Now now we can set them as two different equations, okay? Equal 0, okay? Or to be technically correct, it's the answer. Word would be or instead of and. Negative 3, or separated by a comma. See, here you don't have to use a word. You can use a comma here. I think it's even better. Y minus 3 equals 0. Okay. Add both sides. Add 8 to both sides. Y equals 8. Add 3 to both sides here. Y equals 3. Okay. So y equals 8, positive 8, or positive 3. Okay. And that's the solution for that equation, okay, or for this equation, okay. Again, you need to make sure that you set it in standard form first, and remember that standard form means that your leading coefficient has to be positive and the leading term has to have a power 2, okay. So it equals 0 though. This has to be 0. Okay. I guess those are the only 3 rules that you need to remember. Let's go back to section 11.7. We worked this one out already. Let me see. I believe I have one more over here. Well, I have an example here, letting you know that this is what happens when you solve for x. Like when you have a quadratic here, when you factor, yeah, you have a quadratic and you factor, set equals 0, factor, and solve for x. What's happening is that the points or the x-intercepts and the points where your x-axis intercepts your graph, those are your solutions, okay? Those are your x's. Just pointing that out. I'm not gonna test you on that, okay? And that's the end of the lesson. It's a short lesson, but it has a lot of different variations. However, you already know how to do all the factoring. So the only things you need to remember is to have it in standard form first before you solve, before you factor. Set it in standard form, and the leading coefficient needs to be positive. The leading term has to have a power 2, and set it all equal to 0, because that's what's going to allow us to make it into two different equations, and then solve for x. Alright, and that's the end of this video. I will see you on the next one.